social scientists research phenomena that occur in the population. Given that we are usually not able to conduct research on the entire population of interest, we take representative samples and use the findings from our sample to describe what is going on in the broader population. The process for making statements about the broader population based on the use of sample data from that population is called statistical inference. Just think of the word infer to help you memorize that. Sampling distributions allows for statistical inference based on the central limit theorem, and we will touch on that in the next couple of slides. To create a representative sample, we use a random sampling method in order to ensure that key population characteristics and attributes are picked up in the sample. A sampling distribution is a theoretical distribution based on the probability, which includes all of the possible sample outcomes that we could find if we could gather data using every possible combination of samples. The Central Theorem is a fundamental theorem of probability. Roughly, the central limit theorem states that the distribution of the sum, or average, of a large number of independent, identically distributed variables will be approximately normal, regardless of the underlying distribution. The importance of the central limit theorem is hard to overstate. Indeed, it is the reason that many statistical procedures work. So it is very, very important. The central theorem tells us that we can estimate the mean, central tendency, of the population parameter, the variability of the scores around the population mean, which is the dispersion around it, and its distribution, so the shape. So take a look at the picture right here and the definitions and symbols and have those memorized. The sample has to be randomly selected. You can't cherry pick what you want in your sample. And inferential statistics need samples that are random and from an exhaustive sample. To generalize the sample results to the population means to apply information from the sample to the population. We say that our findings are generalizable if the conclusions from the sample can be applied to the population of interest. When it comes to probability sampling, everyone has an equal opportunity of being part of the sample. So non-probability sampling is a method of creating a sample that does not use a random method of sampling. Therefore, that's how it gets its name. That's an easy one to remember. Non-probability does not use a random method of sampling. In statistics, point estimation involves the use of sample data to calculate a single value, known as a statistic, which is to serve as a best guess or best estimate of an unknown, fixed or random population parameter. Unbiased estimator is if its value equals the value of the parameter being estimated. Mean of the sampling distribution of means is the average of all the means in the sampling distribution. Simple random sampling involves selecting potential respondents based on random method. We refer to it as simple because we are not concerned about the structure of the population, such as gender and location. It's almost like drawing names out of a hat. It's all random. Systematic random sampling is similar to a simple random sampling in that it does not take into account details such as gender and location. Also, like simple random sampling, the intent is to ensure that each potential respondent has an equal chance of being selected for the sample. The difference with the sampling technique is in how the sample is selected. In systematic random sampling, we randomly determine who the first individual will be on the list and then select every nth person thereafter until we reach our desired sample size. Stratified random sampling and cluster random sampling take into account different parts of the structure of the population. So here we do target something, such as gender and location. In stratified random sampling, you first create a strata, so a homogeneous subgroup, based on characteristic or trait of the population, and then perform a simple random sample from each subgroup. The groups in stratified sampling are usually based on personal rather than geographic characteristics. So in our example, we break the population into gender groups and then perform a simple random sample within each. In cluster random sampling, you start by creating homogeneous subgroups, clusters, based on geographic characteristics, and perform a simple random sample from each cluster. So have a look at these pictures. These will help you get a visual of what each one represents and memorize it.
Here I have an example of a sampling frame. So instead of you going out and looking for the population and the subjects for your research proposal, you go to these organizations like ICBC and you get the list from there.
Sampling error is the difference between the sample mean and the actual population mean. So say you take the same test 3 times and the sample mean is different in each one. That is an example of a sampling error. We can decrease the sampling error amount by increasing our sample size. As we increase the sample size, we take in more information about the population. So in my first example, suppose we know on average Canadians spend 8 hours a week on Facebook, and then university students spend 10 hours a week on Facebook. The sampling error is 2, because that's the difference. A sampling distribution of means, also referred to as distribution of sampling means, is a theoretical distribution of all potential values of a sample mean that you would find if you could draw all possible combinations of random samples. Here's another example of the sampling distribution of means. If we were to do that an infinite number of times, the distribution will look like a normal curve. It's going to take on the shape of a normal curve and will be symmetrical. The sampling distribution properties. It's normal in shape, has a mean equal to the population mean, has a standard deviation / standard error equal to the standard deviation divided by the square root of sample size minus 1. So here are some formulas that you may see on your exam. I'm sure you know what the symbols mean. As long as you know what the symbols mean and you understand the concept, you will ace the exam. Don't worry. Make sure you practice these as well. Knowing what they mean is not enough. The sample mean is an unbiased estimator of the population mean. The mean differs from the population randomly. There is equal chance that the mean will be greater than or less than the population. Over the course of a large number of samples, the mean will be on average be equal to the population, so as the numbers get larger. So the standard deviation of the sampling distribution of means, which is the O x bar you see right there, will be equal to the population standard deviation, which is above. There's a symbol of standard deviation, the O, divided by the square root of the sample size down there. So the standard error of the mean tells us how far individual sample means vary from the population mean. So you're going to have to memorize this formula because you're going to be using it every single time on that exam to find the standard error of the mean. As the sample size gets larger, the sampling distribution becomes more normally distributed. Even if the population distribution of the variable is not normally distributed, such as income, because that's usually positively skewed, the sampling distribution of means will be normally distributed.